All right, we on? We're good. So, thank you everyone for coming. Welcome to Crash Burn Report, which hopefully is just the title of my talk and not the feedback and evaluation at the end. So, please bear that in mind throughout. My name is Scott. You may have seen me. I'm fairly active on the Twitters, so that's probably where most people possibly have heard from me before. I also blog quite a lot as well, usually around technology and security on the web. So generally speaking, like encryption, cool things with TLS, HTTP2 that you can do. And what I'm actually going to be talking about today is part of some of the things that I've been talking about and using myself much more recently. Something called the Reporting API, which is a new feature currently built into Chromium. It's an open web standard, currently built in Chrome, coming soon in Firefox and others. And it's about how you can get really powerful and useful telemetry back from the browser. Now, the browsers have been able to do most of the things I'm going to talk about today for a very long time, and it was literally years and years and years ago. I was reading an RFC, I was reading the standard, and I was like, wow, like, you can have the browser itself actually send telemetry back to you. No agent on the endpoint, you don't have to deploy like JavaScript libraries, do any of this stuff. It's all functionality built into the browser. And I was like, wow, this is really cool. Why does no one use this? I would like to use this. So I set off out to find a service that I could send all of this telemetry to that would ingest it and use it, and I could have dashboards and reporting about errors and stuff. And I couldn't find one. I couldn't find a service that would ingest this data. And like all good kind of like hacker/developer people, I was like, oh, I'll quickly whip something together and I'll send the reports and all of the data to myself. They're just nice little JSON payloads, so they're fairly easy to ingest and process. And I was like, oh, this would be cool. Like, I want to see what this telemetry looks like, so I just need to build an endpoint to accept it. So I built an endpoint just for myself. And I was like, okay, well, it's actually kind of useful. I'll open it up, and me and a few friends can use it, and it'll be like a slightly bigger project. And then more and more people use it, and I was like, oh, I should, formalize this a little bit. And I gave it a name called Report URI, which you see up here. And then more and more people used it. And more people kept coming and using this thing that I had no intention of building and running as an actual service. And this is us now. And the reason that I tell you this story is so that I can do kind of the full transparency, full disclosure thing up front. A lot of the technologies that I'm about to talk about in the browsers send telemetry, they send reports, they send diagnostic data, and my service, hands up, like, we can ingest this data. You can ingest this data yourself, just like I did when I first started out, but I'm not here to talk about us and what we do. I just wanted to be kind of open up front of why I got so invested in this area, why I'm so heavily focused on it, and it's essentially because I thought it was really cool and no one was doing it, so I built something to do it, because I genuinely feel that the data and the information and everything that you can get back from the browser natively, remember this is native functionality, was just really, really awesome. So the service has been going as from beginning, it's kind of like 5 years now. As a commercial service, it's probably about a year and a half. So all of this stuff is built into the browser, the reporting API, error logging that we're going to look at, things like that. And whenever I talk about stuff built in the browser, like cool new features, we always have to have the support discussion. Now, as I said, like some of the more cutting edge ones, like the reporting API, which we'll explain very soon, only came out last year. So right now it's only supported in Chromium-based browsers. However, I'm hoping very soon Firefox will have it, and hopefully it will kind of spread over to the right side of this diagram eventually. Some of the things that I'm going to talk about, like content security policy, are supported in every single browser on here, and you can get telemetry back from all of them. Now, in many ways, it kind of doesn't matter. The support thing is not really a big deal, because if the browser doesn't support one of the mechanisms we're going to talk about, it just won't send you any data. Like, that's all that will happen. So nothing will break. It's not critical. It's like, hey, if I can get this useful information back from the browser, awesome. It will send me the useful information. If the browser doesn't support it, then I will hear nothing from that browser, and it will just carry on as it normally would. So the support thing's kind of an easy one to solve, because if it does support it, it's great, and if it doesn't support it, nothing bad is going to happen. You just won't get any reports from that browser, any information. Now, the reason that I wanted to start doing this is years and years and years ago, I was running my own blog, and I'm sure many people here have a website of some description. Maybe it's your company website that you're responsible for. Maybe you run a blog, you have a project that has some kind of website. Maybe you've helped a friend build their website. But we all probably have some kind of online presence like this. Now, I build my blog, I write my blogs, and I want people to come here and read them. I hope that they're useful, and of course I want it to be online and available. I put a lot of time and effort into it. I want to make sure that it works properly. Now, there's lots of different scenarios when that can't happen. Something goes wrong, And if my web application is online and you can't get to it for some reason, something is broken, like I generally speaking would like to know. So what I hope happens is that the browser comes along and sends a request over to my hosting provider where I host my blog. And this is the first opportunity for something to go wrong, maybe with the application itself. And we have loads of different things to help us identify and track these problems. Some of you probably have used or do use some of the things on here. I actually used to use New Relic. More recently, we've moved over to Papertrail. So this is a really cool logging service where if something happens on my application, the error, the exception, all of the information that I need will get logged, and then I can go to the logs and be like, wow, you know, my application server is having a really bad day today. I'm getting loads of 500s, and here's all of the stuff that I need to fix it, because I want to know there's a problem so that I can go fix the problem and then everyone can go to my website. In the other kind of direction, if everything works on the application server, we send the page back over, you get my blog, and hopefully you can read it. But there's still things that can go wrong on the client side. And we have things to help us track errors on the client side as well. And again, I've looked at Track.js. Todd Gardner, the founder of this company, incidentally, isn't here this year, but he usually does the PubConf events here at NDC. So if you've ever been to one of those, you should check out Track.js and Todd's company. But again, there are things that you can deploy and do to track errors on the client side. So clearly, people want to know if something is broken. People want the ability to know if something is wrong. Now, there are some scenarios where none of these tools will help you. Let's take this one. So for the people at the back, they may not be able to see this. I've gone to a subdomain on my website, and it says does not exist.scotthelme.co.uk, which obviously doesn't exist. I don't resolve this subdomain, right? Like there's no IP address for this record. But let's just for a moment pretend that this was like www.scotthelme.co.uk. So you type in www.scotthelme.co.uk, hit the enter button, and you get this big old error message. And it says DNS probe finished, NX domain, which means there is no IP address record for this domain. So let's take the idea of this error, this problem, this broken thing, whatever it is, and let's look at this diagram again, where we just were. Now, if the DNS doesn't resolve, can the browser send a request? And the answer is no. Like if there's no DNS resolution taking place, like there's nowhere to send the HTTP request to. So this thing doesn't happen. And if the request doesn't happen, then how can the application log an error if no requests hit the application? And likewise, if there is no request, there's not going to be a response, because there can't be, and there can't be anything on the client side. So this is the actual setup as we look at it right now. It's just the browser, like, I can't get there. Like, there's no information for me to get to your application. Things can go wrong right at the very beginning, right at DNS, when you try to do this. Now, I still want to know, if this user is trying to go to my website and they're sat at that big error in their browser, like I have all of these other error logging solutions, but my website is broken and I have zero visibility. That user is just sat at that error message, and as far as I know, they don't exist, like, because I've never seen them before. So this is one of the first things that we're going to look at fixing. This and many other types of error like this, with the thing that I mentioned earlier called the reporting API. Now, with the reporting API, one of the things that we obviously have to solve here is if the communication between the browser and the actual host itself breaks down, and this doesn't exist, then none of those logging mechanisms that we talked about could work. But also, if you can't communicate with the host, you can't send the diagnostic information back to that host. Let's go back to the DNS not working. Okay, there's been an error on scotthelme.co.uk. Let's try and send the error log to scotthelme.co.uk. It's like, well, we can't connect to that host, which is why the problem exists. So we also can't send the report to that host. Obviously, that would not work. So the reporting API introduces an out-of-band reporting mechanism where you can send the report data to any endpoint of your choosing. Now again, yes, like full transparency, we will ingest these reports for you, but you can specify absolutely any endpoint that you want. Of course, you want it to be off-domain, because if for some reason they can't get to your application, you need a reliable third-party location to send these reports to. Now, like I said earlier, there's no code or agent to deploy here. Every single thing that I'm about to talk about is native browser functionality. This is all built in to the browser itself. All you have to do is ask the browser to send you the report. Now, to ask the browser to do that, we have to deliver, first of all, something called the report to header. Now, this is a HTTP response header. There's some headers up there that you're probably really familiar with, like the server header, the date header, cache control, etc., etc., etc. You just add a new header to your response headers called report to. And this indicates to the browser, like, hey, I would like to turn on this cool reporting mechanism, and you send the configuration as JSON in the header. So let's just expand that out, take a look inside what that JSON might be. So first of all, you can have a group of reporting endpoints, and you have to give it a name. Here I've just called mine default, just to keep things nice and easy. So it's group default. Now the max age one, this is probably kind of where the magic is happening, because max age is the number of seconds that the browser should cache this policy for locally. And this is how we fix the ultimate problem. Like, let's say I go to your website and I can't resolve, I can't connect, something fails, something breaks. If I can't get the policy back at that point in time, I need to remember the policy from a previous visit. So by caching it like this, the browser will be like, oh, well, I'm trying to go to Scott's website and that's broken. But I remember the last time that I went there, he said, if something goes wrong, I want you to send me the data. So this ability to cache it is how the browser can still send the telemetry in future situations when for some reason it can't connect. So this is probably the true magic part. Next, endpoints. I've just got an array here with one entry. You can specify in order that you would like the browser to try them, where you would like it to send the reports. So here I've just got a demo account that I set up. We can send the reports here, and you can do whatever you wish with them once you've received them. You can specify multiple endpoints, and the browser will try the first. If it fails to deliver for some reason, it will try the second, so on and so forth. The last part is optional, includes subdomains. So if I delivered this policy on scotthelme.co.uk, do I want the browser to also send all of the following reports about any subdomain that it tries to connect to? If you do, if you want like full coverage of your entire site, then you can set true. If not, you can set this to false and say, I just want reports for the domain that delivered the policy. So hopefully this is really easy to set up. All you have to do is configure this single HTTP response header. And this indicates to the browser, I would like the reports, and this is where I would like you to send them. What you have to do then is kind of like choose the information that you want, like the types of reports that you want. So this is where the reports are going to go. Now we're going to look at saying, I want some really specific types of information from you. We have something called network error logging, which, as you might guess, is about network errors. Now, network error logging covers a whole load of super useful stuff that I just can't see another way that you could possibly know about. Let's take all of these error types. So I've just grabbed a few snippets of the different error types that you can get through NEL. DNS unreachable. For some reason, the visitor to your website can't contact your DNS resolver. Name not resolved. Are they going to a subdomain like the one we saw before that you're not resolving? We've got DNS lookup failed. Is your DNS provider having a bad day and people can't get to your website? Or DNS address changed as well. So have you recently reconfigured your DNS addresses? And you can see the changeover point in the client when your DNS changes are being kind of reflected out into the wider world. But let's say DNS works. So I do the DNS lookup, scotthelme.co.uk, I get my IP address. Still loads of different things that can go wrong here before we actually get to a working web page in the browser. What about TCP? Because once we've got the IP address, the next thing that we've got to do is make a TCP connection. And there's a whole raft of things that can go wrong there as well. Timed out, connection was closed or reset by the server, it was refused. If you've got a load balancer having a bad day, TCP aborted, invalid IP address, the IP address is unreachable, are you having some routing issues somewhere? Again, all of these are scenarios where the client is trying to get to your application and it can't get there. After TCP, what's the kind of big cool security thing on the internet at the minute? Everyone's trying to deploy HTTPS. It's new for a lot of people. People are having a foray into encryption for the first time. There's lots of moving parts of TLS, protocols, configurations. We've got to buy certificates, renew them every year. There's a whole heap of stuff. And when we're doing new stuff for the first time, it doesn't always go perfectly. There's a whole load of TLS errors that you can get information about as well. Version or cipher mismatch. Have you got a good configuration on your server? Certificates, invalid, date, invalid. Have you served the wrong certificate, an old certificate? Did you forget to renew it and it's gone past its expiry date and you're still trying to use it? So again, if one of these errors happened and the client can't get to your website, none of your current application logging will help you because the client never got there to make a request in the first place. And the final one is then up to the application layer. Maybe we eventually make it all the way through DNS and TCP, TLS, and we send the HTTP request. And these are the last few kind of errors that we can catch. The one here that I see most often, whoever sees this, the redirect loop on HTTP, I often find this when I'm trying to do like third-party identity providers and they redirect you back to the site. And I just end up sitting there for like 5 seconds and then the browser's like, I give up. Too many redirects, like we're just gonna stop here. So there's loads of really useful information. There's more than this as well. I just thought I'd pick up some of the cool ones that I liked. That's a lot of stuff there that the client, the browser, can tell you about. There's loads of different scenarios where a client may genuinely not be able to get to your website and you would otherwise miss them. So the biggest one on here for me has to be around TLS. So there's a really cool demo website you can go to online called badssl.com, and you can look at loads of different pages, and they have intentional misconfigurations on each page. And the one that I'm looking at here particularly is expired. So if you have a certificate on your website for HTTPS and it expires, generally speaking, they're valid for like a year, and you have to buy a new one. If it expires, you can see like this is how Chrome would treat my website if I went to my website and the certificate had expired. So it's really nice to see like what the client does in these different scenarios. Now again, if this was your website and the client went there, you wouldn't get any knowledge or any information. There would be no error logs tripped or sent anywhere unless you were using the reporting API and you would ask for network error logs. But that's maybe not strictly true. Maybe there is one place where you would get some information about this. So we're going to take a look at the NEL header first, and then we'll kind of move on to looking at what we can do with this data. So if you want to subscribe for any of the reports that I just talked about, you have to issue an additional header. So remember earlier, the report to header is essentially configuring where the data gets sent. The NEL header is now saying, okay, I want these network error logs. So you issue the NEL header. The report to directive says default. That was the name of the group that I specified earlier. So just saying, take these errors, send them to the default group and whatever endpoint that specifies. And again, max age, very similar thing. This is the number of seconds that we would say, right, I want you to remember this such that if you come to my website tomorrow and it's broken, you'll remember that I want these error reports and where to send them. Because without that information and it's broken tomorrow, this wouldn't work. So the client has to cache this, and it has to cache it for at least a reasonable period of time. Now, when these errors get tripped, when someone goes to your website, your DNS is broken, your certificate's expired, whatever it might be, this is what we get. This is what the browser will dispatch to that endpoint, a nicely formatted JSON payload. And it will tell you all of the information that you need about the appropriate error. So let's take a look through this. First is the age. Now, the age is the number of seconds that the browser has been storing this report locally. As soon as an error happens, the browser will try to dispatch the report. So generally speaking, the age will be 0. But if the client's like, I'm a bit busy, the network's a bit slow, or the service at the other side isn't responding, the client can hold on to the report for a period of time. Maybe your Wi-Fi connection's dropped. And it's like, okay, you know what? I'll try again in 15 minutes. Maybe we'll be back online. And then you get a max age of 15 minutes worth of seconds. So that when you're receiving this, you can know if the error happened immediately, just a moment ago, or perhaps it happened 1 hour ago. Next field, we've got the type. In this particular instance, we're looking at a network error because we're currently talking about network error logging. The URL, where was the client trying to go when the error happened? Then in the body of the report, we have the sampling fraction, first of all. Now, if you're a very high traffic website and you have a problem, let's say you get 1 million visitors an hour, and for 1 hour you have a little bit of a problem on your website. You're probably going to get just like fire hosed with reports because all of these 1 million people coming to your website are going to be like, hey, your website's broken. And you're going to end up with just this massive quantity of reports. So with the sampling fraction, you can say, actually, you know what, I only want 0.1, and this is between 0 and 1. So I only want 0.1, 10% of my clients to send reports. And they'll just randomly downsample and send you a smaller volume of reports. If your website's broken, you don't need 1 million people to tell you that it's broken. 1,000 people telling you it's broken would be enough for you to know that it's broken and to go fix the problem. So this is a really cool, handy feature to just slow down that volume. The referrer, in this case here, is not set, but if there was a referrer set, it would be here. There is no IP address. There is no protocol here because the connection wasn't made. It would have made a GET request had it made a request. There's no status code again because there was no request. There can't be. The elapsed time. So this is how long it took the browser to do the action it was doing. So from me hitting enter to go to the domain, it took the client 92 milliseconds to get to the failure. So because this was a failure at TLS, obviously it's quite early in the connection. If it was a HTTP request, we'd expect to see a slightly longer time to get to the point of failure again. So 92 milliseconds it took here. And then probably the most important part is the actual, essentially the reason that this happened, the type. So here, TLS.certificate.date invalid. So I would be like, wow, I bought that certificate last year and it's just rolled over 12 months old and past its expiry date. I now know that people are getting that big red error message when they come to my website because my certificate has expired. And this happens so much at the minute, largely because more and more people are doing encryption and they're all really kind of new to it. And like you say, you've got to build the process. You've got to get good at this. And it's not just small organizations either. We've seen some really big companies have trouble with this. And it's obviously a hard thing to do if people keep doing it wrong. But it would be great to have this detection mechanism, this capability to know that it's gone wrong, because we do actually have one now, and it is really, really reliable. If you have a certificate on your website and it expires and it breaks, there's like an almost real-time monitoring and alerting solution called Twitter, where loads of people will come and tell you that your website is broken because your certificate has expired. Now, network error logging is slightly more reliable than Twitter, and it won't be me that comes and gives you a little poke online and it's like, hey, do you know your website's broken, by the way, it's not working. So this was, LinkedIn has country subdomains. So ours, you can see there, uk.linkedin.com, and there's all the other country ones as well, with all the 2-letter country codes. And the certificates for them, someone forgot or the renewal process broke or something went wrong and they all expired. And I was in the middle of a training course. I actually do a training course on TLS, on encryption. And, I'm there in the middle of my course and I'm like, oh, let's go look at some big companies and who they bought their certificates from to see which vendor is being chosen. And I load up the website, it's like, pow, certificate expired. It's like, oh boy, this is not good. Let's go and tweet them and tell them to see if they're aware of this. Now, I love this next one as well. Take a look at this one. This is Tesco's, Barclays, sorry. It was a really big bank in the UK on their home insurance part of their website. I love this bit though. I don't get this. Is a different browser going to take you back in time to when the certificate wasn't expired? I'm not sure. I don't know why. I don't know why using Firefox would take you back to yesterday, but apparently it will. So, again, network error logging isn't going to forewarn you that something will break tomorrow, or this thing will break next week. Hopefully you will catch it before then. Hopefully you will renew your certificate. Hopefully you won't have any downtime on your DNS. Your applications will always be healthy. But if something has gone so wrong that the user is going to be getting these giant big warnings in the browser, because that's what all of these errors will trigger, then I would like to know about that as soon as it pops in the browser. As soon as a user is sat on my site with a big red error message, the browser will send that report in the background. And that's really what I want, is as soon as it's gone that wrong, I would like to know about it. Now, to look at just how bad this certificate thing is, because this is pretty widespread, I kind of repurposed some data from one of my projects. So I have a project called crawler.ninja, and I have a fleet of crawlers. And every single day, they fetch a list called the Alexa Top 1 Million. Now, Alexa is a web analytics and ranking company, and they say, hey, this is the top 1 million websites by traffic every day by day by day. So you can go and grab the list and be like, who's the number 1 website today? Who is, number 2, all the way down to 1 million? So I grab this list every day and say, well, these are the biggest 1 million websites in the world. So they're, the most funded, they're the most traffic, they probably have good teams and tools and process, right? If anyone's going to do this stuff right, you'd think that the biggest websites in the world would be the ones to do it. So my crawler takes this list every day, and I look at all kinds of different security metrics about these websites. You can go look at it. These are just 3 samples of the raw data, and it kind of spits out some additional analysis. And some of the files that it spits out, you can see here. So certs expired. This is websites in the top 1 million websites in the world that are currently serving an expired certificate, which means if you go to that list and grab one of the domains and try and go to it, you will most likely see a big red warning in your browser. Now, the crawler pumps out this data overnight, so I would have crawled it yesterday, I would have done the analysis at midnight, and obviously we're at 3 p.m. in the afternoon now. There is a chance that if their website is broken, they could have fixed it in that time. So bear that in mind. But generally speaking, you can just go pick ones out of this list. The better list, and I did this in January when I was last in Norway. So I was at NDC Security just over town. And in the demo section very soon, I'll look at the certs expiring in 1 day. So when my crawler saw them yesterday, it meant they had less than 24 hours left on their certificate until it expired. And that's a really small time window. And remember, I looked at them yesterday. I did the analysis overnight. So generally speaking, right now, if they're still using the same cert, they probably have a matter of hours left until their website breaks. So I went into this list and I searched for .no. I was like, hey, let's see if there's any, Norwegian domains. I always do a local thing. And I found this one website and we went to it and I was like, oh my God, their certificate expires in 38 minutes. And I'm in a 1-hour talk slot on a stage. And we got to the end of my talk slot. Niall Merrigan, who's another speaker here, he was on after me. So he got up, got his laptop up, and he's like, hey, let's just go to that. Oh no, and it's like giant big red warning on the screen because it happens, and it happens so often. And that website operator would most likely not find out about that until literally someone told them. So it happens a lot. Go check out these files. They're kind of cool. Also make sure that you're not on these lists. So that was just network error logging. But there is so much more that the browser can tell you about. Network error logging is obviously very focused, very specific. We looked at DNS, TCP, TLS, and a little bit of HTTP stuff as well. But we're going to move on to some more things that the browser can tell you about. Next, we're going to take a look at deprecation reports. Now, this was actually a real thing that happened in the UK, and it probably happened more widely, but I was just focused on researching in the UK. We have lots of retailers in the UK with bricks and mortar stores. We've got supermarkets, we've got appliance stores, we've got all of these things. And then they have their website. You know, you can generally go and buy online, or you can do like this click and collect thing. It's like, I'll pay for it now and I'll go pick it up from my local store. And then you go to their website and they have like a map, and you can click locate my nearest stores. Everyone must have seen one of these at some point. You can go into like a pizza app and it's like, I'll collect the pizza, click where is the nearest store, and it gives you the directions. Now that's really powerful, that's really useful, and there's a lot of convenience in that for the user. And Sainsbury's is probably like the second largest supermarket chain in the UK. And just like everybody else, they have one of these features on their website. If you want to find your nearest store, you go to this address and you just click on the little button there and it will locate you, therefore the nearest store, and it will give you the directions to get there. Except one day, just normal day of the week, everyone started going to this page as usual, and you click the button and nothing happened. Like absolutely nothing happened. It was like click, 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 click. Like what's the thing? The button does not work anymore. It doesn't do anything. Can anyone here tell me why, and all of the information that you need is on the screen in front of you, can anyone here tell me why this button doesn't work? Because the page is on HTTP. Did anyone spot that tiny little nuance up in the top left corner? That this here is a HTTP page for stores.sainsbury's.co.uk. Now, let's say that this was today, okay? So like today, you go to the website, you click the button, nothing happens. But it all worked yesterday. Yesterday, you go to the website, like you click the button, it's like, pop, here's the directions. Off you go to your local store. Today, you click it, nothing happens. Because the browser vendors, in their kind of constant improvement of security and privacy online, we're looking at what we call powerful APIs. Now, the geolocation API is a fairly powerful feature to have in the browser. If you click this button, it will take the GPS coordinates of your device or phone, whatever it is, and it will send, of course, the GPS coordinates remotely to say, right, this is where I am, like, tell me where the nearest store is and give me the directions. If you're sending your GPS coordinates over the network, and the page is on HTTP, your GPS coordinates are going to go over the network over HTTP. Now we talk about sensitive data. I know the GDPR thing's been really big recently, but your GPS coordinates down to like 6 digits is like who is in that square. And that's like fairly personally identifiable because it's pretty much me. So they were like, maybe we shouldn't send this potentially sensitive data over HTTP. And the browser vendors agreed this was a great idea. So we're going to disable that feature on HTTP. Now they wrote a blog about this, okay? Chrome and like Firefox and the vendors are like, hey, on our developer blog, we're going to turn off this GPS thing on HTTP, the geolocation API. Everyone, of course, reads all of the browser's developer blogs, right? Like you all knew this was coming, didn't you? And this is kind of the point, right? It's like, really? Like even I struggle to keep up with these things. But of course, things that you use are going to stop working. We call that a deprecation. Chrome deprecated the geolocation API on HTTP, which meant that their website, or this particular piece of functionality on their website, completely stopped working. Now, many people would say, well, this is, you know, kind of the developer's fault, the owner's fault, the company's fault. Like, they should have kept up to date with changes in the browser. And I'm not really sure that that's fair or scalable. Like, I don't think that we can expect people to keep up to date on like what literally every browser vendor is doing. So we fixed this with deprecation reports. Now, we didn't have deprecation reports back then because that was years ago. But this is like a perfect example of why we need deprecation reports, because we can use features in the browser that will stop working. And if we had deprecation reports back then, and for anything that you use now that the browser vendor intends to turn off in the future, as soon as you use that feature in the browser, it would send a report like this. So we can see now the type has changed to deprecation. The address, we were trying to go to stores.sainsbury's.co.uk. The body, the ID of the report, is the geolocation, is what's triggered this report. You can see the anticipated removal date. So what it's saying is you're using a feature on your site currently that we intend to switch off in the future. And then it will give you this nice message. Geolocation is deprecated over HTTP and will be removed in Chrome 50. Now, if they'd got this 1 month before, which they would have if we had this like 3-4 years ago, could you go fix that before it actually broke in the client? And it's like, yes, this is exactly what deprecation reports are for. And we're seeing more and more of these being sent at the current time and going forwards. As Chrome now intends to deprecate features in the browser, if someone goes to your website and uses that feature, the browser will send this report and say, hey, I've just come to this page, and you're using this thing that we are going to turn off, and it will stop working. So if you get one of these reports, if you subscribe and say, yes, we would love to know about this, if you get one of these, it's generally speaking going to be something that you need to action, and usually fairly soon as well. You're probably going to have like a month or two before the thing that you're using will stop working. So to me, this is really useful. In some ways, it's better than NEL because it's actually a deprecation ahead of time. So you have the ability to fix something before it breaks, and I think that's far more useful. But there's still more. That was just deprecation reports. The next type of report, intervention reports. Now, I actually quite like interventions and the whole concept of intervention reporting. Has anyone ever gone to a website? I'm sure your browser looks like my browser. Who has more than like 10 tabs open, right? Like, just let the record reflect, it was like everyone. So like you're sat there, you're doing something, you're reading your emails, and then like some music starts playing. And it's like, where the fuck is the tab? And you're like going through tab, like which of the tabs is playing the goddamn music? Like I need to turn the music off, and I have dual monitor as well, so I have like another 50 tabs on the other side, and then I'm going over here and I'm like, oh my God, this is so annoying. Like why is this application doing something that bugs the hell out of me? Now, websites can do things like that are annoying for the user, that they give a bad user experience. There are things that pages can do that are bad for security as well. There are pages that do things that are bad for performance. Now, historically, the browser would just do these things. You go to a page and it says play the annoying music, and it will play the annoying music. You go to the page and it says do this like terrible performance thing in JavaScript, and it's like, yep, awesome, let's do the terrible performance thing. But now again, the browsers are changing their stance. If you go to a web page in a browser and the browser says, you know what, this might be annoying. Like if we start playing this background video that the user hasn't clicked on, that might bug them. That might be bad for their experience. So we're going to intervene. We're going to step in and say, the page asked us to do this thing, but we're actually not going to. We're going to do something else or not do it at all. But we're going to intervene and do something other than what we were instructed to do. Now, we call this an intervention. And here is the kind of intervention report that you might expect to see. You think, hey, great, yeah, like our marketing team wanted us to autoplay this video on the marketing page. But actually, half of the browsers out there aren't playing it because they deem it to be a user annoyance. And you would get a report. A request to play audio was blocked because it was not triggered by user activation such as a click. So you think people are going to your website and having one experience, but they're actually having a completely different experience because the browser intervened and behaved differently in order to protect either the user experience, security, or performance. Those are generally the three main reasons we see the browser intervene. The often ones are things like we didn't load images or fonts because we have reduced network bandwidth. If you go to a website and they're on a terribly slow connection, you can get intervention reports saying we didn't load the font files, we used the fallback font instead. So again, like you might be expecting people to come to your website and see a certain thing, but it looks very different for them because the browser didn't do part of what it was supposed to do. Now, I kind of agree with it. I agree with the stance that the browsers are taking. They're trying their best to look after the user. And remember, we call the browser a user agent. So it's an agent that acts on behalf of the user, so it will always have the user's best interest in mind. So what I think is important, though, is that we know these things are happening. If we expect one thing to happen on our site and a different thing happens, like I would kind of like to know about that. You know, if I'm doing something that's really annoying or bad for performance or bad for security, great, tell me, and I'll go fix that. I'll do it differently, I'll do it properly. But I need the information in order to start doing that. So that was intervention reports. And the last one in this section that we're going to look at before we move on is crash reports. if my application, if my site manages to crash the browser, that would be pretty good to know, because I would like to know about that. Now, right now, there's currently only one type of crash report that you can get. This is really, really new, and this is going to be expanded over time, but right now, there's one particular crash report that we can get. And we're probably only going to get it from Chrome, and you'll see why now. Crash. On this page, a unique crash ID, so you can go look up the error report, and then the reason, out of memory. Now, arguably, this is probably not ever going to be your fault if the browser was Chrome. Like, we can have that discussion offline. But again, if your application is so big and so heavy, maybe you don't, like, maybe not all of your visitors are on iPhones with like 32 gig of RAM or whatever. Maybe you have visitors that are on generally lower powered devices. Maybe it's a low powered computer. Maybe it's not something that's particularly great. Maybe it's unrelated to that. But if you're reliably crashing the browser when it comes to your site, I kind of would like to know about that too. And now we can. So that's all of those 4. But there's actually more than that. And I'm not going to talk about the rest of them because I want to move on to the next section. But if you are interested, this is probably the slide to take a picture of, because these are all the extra things that you can go away and look at to get even more information back from the browser about various different errors. Content security policy is so powerful. You can restrict things like, where do I load JavaScript from on my website? I only load JavaScript from myself and from code.jquery.com, no other JavaScript. And the browser will say, got it. And then it comes to your website and it sees a script tag. And it's like, whoa, hang on, this script tag's loading from evil.com. Well, you didn't mention anything about evil.com, so I'm going to block the script tag and I'll send you a report to tell you what happened. Fantastic. I now know there is some shady JavaScript on my website, and I should probably go fix that. HPKP, you should try reading up on this one. This mechanism is so powerful that Chrome is, depending on what current version we're on Chrome, they might have deprecated it. So they're either currently deprecating it or it's going in like the next version, because this feature was too powerful and people would try to deploy it and break their website. So have a read on that one if you like controversy. CT, or certificate transparency, as we call it. More and more people are getting HTTPS for their websites, as I said. And to do that, you've got to go buy a certificate. You can get them for free from a couple of places as well. Now, if I have a certificate, it means that I am the website that I claim to be. If I have a certificate that says I am PayPal.com, I am PayPal.com. They can sometimes accidentally be given to the wrong people. Now, with certificate transparency, you can go and do a search for all certificates that have been issued that contain your domain name. So if you're like, okay, well, we've got this certificate and this one that we bought, and you can go do a search in the public record and be like, whoa, hang on a minute, like, what's this other one over here? Like, we didn't buy this one. Someone over here has a certificate with our domain name that's not us. You should probably know about that so you can take action. So check out CT and have a look at that. Feature policy kind of hooks in a little bit to the geolocation stuff I was talking about before. There are so many powerful features in the browser now. You've got the geolocation API, camera, microphone. We can hook into USB devices on the client. There's all these kinds of super powerful things that the browser can do. Now with feature policy, you can enable or disable those features on your site. If you go to my website, in my feature policy it says camera disabled. So there is no possible way that I can trigger or use that API on my site. And the biggest protection here would probably be, what if I have like ads, right? Like we have to pull in third-party JavaScript, and every now and again a little bit of bad JavaScript gets in there. You go to my website and it pops up at the top. This website is requesting camera permission. Would you be particularly happy with that? Probably not, because you're like, why the hell is Scott requesting my camera permission? He really doesn't need this. If I set feature policy header and put camera disabled, it will not be allowed to use that. So I can make sure that not my site nor anything on it can use it. Microphone API. Scott would like to access your microphone. How many people are going to click on that? And it doesn't look good to me as the site operator. So if you know that you don't need to use the camera or the microphone, then just turn those features off and they can never be used accidentally or maliciously. Next up, the XSS auditor. So the JavaScript example I gave you at the beginning with the script from evil.com, that would be what we call a cross-site scripting attack. Now, not everyone has the time to set up CSP, Content Security Policy. And aside from that, the browser has something called the XSS auditor built in. And this is an auditor built into Chromium-based browsers that will look at the page and try and identify attacks against the user, specifically cross-site scripting attacks. And if it sees one, it will step in and say, hey, like you, the user, because I'm here to protect you, you have just gone to this page, and this page looks like it's got some hostile attack happening on it. So I'm going to block the page from loading. Now, the auditor is built into, as I said, all Chromium-based browsers, which is Edge now as well, weirdly, and it's already turned on, and it's already working. What you can do with this is ask for the reports back from the auditor. You can say to the auditor in the browser, hey, if you block what you think is an attack on my website, send me the report back. And the report will also, and this is a really cool part, it will include what it thinks is the bad part of JavaScript. It will include what it thinks is the thing attacking your user. So you can really properly investigate that. Now, whether or not you want this thing, it's already turned on. All you're doing here is saying, tell me when you take protective measures for my user. And you should probably really want to know about that. If it's got to the point where the browser is like, you know what, this user is under attack and we're going to save them, I really want to know that that just took place. And right now, by default, you won't. Last one, OCSP stapling is a really good performance and privacy feature for websites that use HTTPS. If you don't know about this or have it turned on, you should absolutely check it out. It will make your website go faster, and it will protect the privacy of your visitors a lot more. I actually have a blog post on that one if you'd like to read it. But there's too many things for me to talk about. There are too many things for me to go into the depth that I would like. So do check out those things. That was like a very high-level introduction to them. Now, for the last section of the talk, I want to change the tone slightly. So we talked all about HTTP and web pages and browsers and everything like that so far. For the last section of the talk, I want to flip it around and talk about email. Because email, well, email pretty much makes the world go round, right? Like 10 years ago, I lived my entire life on emails, and I still pretty much live, apart from, well, emails and WhatsApp now, but pretty much live my entire life on emails. And we see a lot of problems with emails, spam emails. Emails that you didn't want in the first place, that you didn't ask for. But not only that, emails that impersonate people. Now, as I have like a few followers on Twitter, I don't know if there's like some correlation here, but I've seen people sending emails that claim to be from me when they're not. I run security headers, I run Report UI. Maybe they're going after some company stuff trying to impersonate me. Like, I don't actually know why they're doing the thing that they're doing, but I know now, thanks to DMARC, what we're about to talk about, that people out there do actually send emails that are trying to impersonate me. And with DMARC, not only can I detect that, I can also attempt to prevent it as well. So DMARC, by its full name, is the Domain-Based Message Authentication and Reporting Conformance Protocol. So DMARC from this point forward now. So DMARC kind of changing the game. We're going over to the email side of things now. Let's say we get this email. So to whoever it's going to, it's claiming to be from my company. No reply at report-uri.com. And it says password reset in the subject. And you're like, oh, wow. I just got an email from Scott's service, and it's like, you got to reset your password for whatever reason. Please click on the link down here. And you look at the link, and it's like, oh, okay, like, report-uri.com. Kind of looks all right, kind of looks like the right link. But of course, this is just hyperlink text. And behind the actual hyperlink, it's not going anywhere like report-uri.com. It could go anywhere. But that email's not from us. That email was sent from someone who claimed to be no reply at report-uri.com. Now, many people will say, well, the user should click the link and make sure that the page that they go to has the correct address. And it's like, I clicked the link and something that looked exactly like Report URI came up. Right? That's pretty much the user's job done. As long as they don't go to some completely other random website, they're probably going to be happy with that. But I also don't think that we should place the burden on the user. Me as the service owner, I own this service, I operate it, I should take measures first. And with DMARC, we can. Now, there's two prerequisites for DMARC, and the first is something called Sender Policy Framework. Now, when you send an email address, it's of course coming from an IP address, right? We've got our mail server out there, you trigger a password reset, and we're like, okay, call the API, send the email, and that email will originate from the IP address of our mail server. Now, that would be a useful piece of information for people in the wider world to know. If I receive an email that claims to be from Report URI, I can obviously see the source IP address, which is handy, but where do I cross-check that information? How do I check that Report URI is actually sending emails from this address? And this is what SPF is for, because you create a new DNS text record. Version, SPF1, that's where we currently are in the standard. And then we have this include directive, and you include all of the locations that you expect to send emails from. Now, we use a third-party provider for this called Fastmail, and they have spf.messagingengine.com. So what this is saying is you receive an email from me, you look up our SPF record and say, right, all of the emails from Scott should have been sent from an IP address that this resolves to. So you go resolve that domain, you get back the list of IPs, you look at the source IP that you got the email from, and you check it against the list. And you say, awesome, we have a match. The IP that it came from is on this list, and we know that that is a server Scott has told us that he will be using. If it's come from an IP that's not on this list, you already have your first piece of information. It's like, well, this email claims to be from Scott, but the server IP that it came from is not on the list of IP addresses that he told us. So this is our first piece of information that we can use to perhaps be suspicious this might not be a genuine email. The second thing that we can enable is something called DKIM. Now, DKIM is domain keys identified mail, if anyone wants the full name, and it's very slightly different. What I do is I configure my email to essentially put a cryptographic signature on the email when it sends it to prove its authenticity. So my mail server, when it sends an email to any one of you, it will put a cryptographic signature on the top and say, this is my proof that it definitely came from us. And then it will send you the email. But when you get that email, you need to check the signature is genuine. And again, very similar process. We create this DNS record here, and into this record we put our public key. So again, you receive this email. First of all, you'll do the SPF check. Okay, the IP address looks good. Happy with that. Move on to the next check. Let's check the signature. Reach into DNS, pull back the key, and check the signature matches. And if the signature matches, you're then pretty confident. It's like, okay, the IP looks good, the signature looks good. We're really confident that this email definitely came from Scott. However, if SPF doesn't match, or DKIM doesn't match, or both don't match, you can get more and more suspicious as those things fail that this email probably didn't come from Scott and may just be trying to impersonate him or his company. Now, that's really good. SPF, fantastic, easy. DKIM, you would probably only do that if you have a hosted email provider. So if you're on like G Suite, Office 365, Fastmail, whatever, it's just like copy and paste this thing from their dashboard into your DNS, done. So it's super easy to turn these things on. But again, it's kind of like before. This is the protection mechanism, right? Like if SPF and DKIM fails, someone might just toss that email away and say, this isn't from Scott, we're just going to throw it in the bin. But I still don't know that someone out there is sending emails impersonating me. And this is where DMARC comes in. DMARC is how you ask for that information. If you're receiving an email from someone over there that claims to be me, they send the email to you and you say, this looks really suspicious, we're going to toss it in the bin. That's fantastic because that dodgy email that went to you went in the bin, but I don't know. And I would really like to know if someone is trying to impersonate me. So with DMARC, again, we set this very simple DNS text record and we specify what we would like to happen. So version DMARC 1, still where we are. Policy. Quarantine. Now you can ask people that receive these suspicious emails to take no action, to quarantine them, which generally means put them in the spam folder for most providers, or to actually discard them and just say toss those things away and reject them. So I'm kind of testing at the moment. I want to make sure everything here is perfect, so I've gone with quarantine. Next option down, RUA. This is where you would like the report sent to. Now, DMARC reports are sent via email, so you have to specify an email address. As you can see, again, reporturi.com, we can also receive these emails, parse them out, make pretty graphs and dashboards and whatnot. You could just have them sent to your inbox and read them from there. They're XML, so you have to kind of read XML, but you can have them sent wherever you like. SPF and then DKIM, do they have to match, and how specifically do we want them to match? Well, I want both of these records to match. So SPF and DKIM, if you receive an email from me, what I'm saying is the SPF and DKIM should both be checked and should both be correct. And if one of them is not, or both of them is not, and I send an email to Gmail that's trying to impersonate me, this is what they do with it now. So someone sends an email to a Gmail address and they're trying to impersonate me. Gmail, like all good email providers, will check SPF and they will check DKIM. Do they match? No. Now, I asked for the quarantine earlier, essentially kind of like put it in spam. Google doesn't have quite the similar concept, and I actually prefer this, I think, in many ways. They just put this like honking big warning on the on the email that is like, beware, be careful with this message. Gmail could not verify that it actually came from report-uri.com. So it's like this email is claiming to be from them, but we couldn't actually prove that. So to me, this is really powerful because that's a really clear indicator to the user that received this. Now, if you received this and it was a password reset email and it had this huge, giant, big warning at the top, would you be likely to change your behavior? And I think it would be fair to say yes, like you probably would. You don't have to look at the link and see if it's the right website and inspect the URL and all of this crap. That's pretty clear that something suspicious is going on here and is far more useful to the end user. Hotmail, Office 365, they do have the concept of a junk folder, so here is exactly the same email that got sent, and you can see that they've just gone wham, straight in junk, and away it goes. If you're reading an email from junk, again, you're probably more likely to treat it as somewhat suspicious than if it landed in your inbox. Now, once I go a little bit further with this, and once I have kind of built my confidence that everything is configured properly. You don't want to turn this on in delete mode whilst you're still learning it, right? And this is the process that we go through. Very soon I will change this to reject. Once I've built that absolute confidence that I'm doing this properly. Once you turn it to reject, you won't get this email or this email. It will just vanish. It will be deleted by the email provider. If you can say with confidence that this email did not come from Scott, just toss that thing straight in the bin. Don't even give it to the user for them to make a decision. Because whilst I think this one is fairly powerful message, I still read a lot of stuff out of my junk that's actually useful. I don't know about you guys, but I actually do get quite a few handy emails that I wanted in my junk folder. So there is still the argument to be made there. Even with things like a junk folder, it could still be quite an effective phishing email that we send to a user. So that's DMARC, and that's currently where I'm up to. Very soon I will be on a reject policy, and then hopefully no one will be able to send these emails to me. So that brings me to the end of the talk section, and what I want to do is just do a couple of quick demos. So I prayed to the demo gods this morning. They're all going to be nice to me. So I've got just a couple of quick demos that I want to line up here to show you exactly what this looks like. So I'll just reload this up and then put it on the big screen for you. And hopefully the NDC Wi-Fi is good. Let's check. Okay, I'm on the Wi-Fi. This looks promising. So, here we go. Yep, sorry, I'm just lining all the demos up. I don't only see it fail if it doesn't work. So now I will put it on the big screen for you. So, here we go. Now, I've got this page here. First of all, I'm going to demonstrate CSP. Now, I gave you an example earlier of somehow a script tag got onto my site. And you can see a script tag up here at the top. Hopefully, I'll just zoom in a little bit, just for people that may not be able to see this. I'm not sure how far away you are at the back up there. It's actually quite high, isn't it? So we'll zoom in there. So I've got this script tag at the top of my page. Now, I've intentionally put this script tag on my page. And also, by the way, the page is live. So if you want to replicate this yourselves right now, you can do. You can see it is just here. And again, I'll zoom in down there. Now, that is a valid script tag. You can see it's even been syntax highlighted because it's all perfectly legitimate. Now, you and I all have a lot of information that we can look at this script tag and say, I don't want that script tag on my page. Raise your hands if you want this script tag on your page. Right, there's like one person in the back, don't know why. But the browser doesn't have that context. We can look at this and be like, evil.com sounds a bit dodgy. Keylogger.js, pretty much sure at this point that I don't want this, but the browser lacks that context. However, if I go over here to the console and take a look at this, we can see it says here. What does the browser say? The browser says, I refuse to load this script, evil.com/keylogger.js, because it violates the CSP. Now, this is really handy because I've told the browser that I pretty much only load JavaScript from two places. And if you see JavaScript from somewhere else, you kick it in the bin and send me a report. Now, this is the report in the console. Of course, this is kind of handy for me to make the demonstration here. But if this was your browser, I'm not looking at your console. I need the information to come back to me. And that's where the reporting API comes in the background. Because if I go over to my account, what we can do, and I'll just grab the URL of the page to filter on, I can come over here and say, show me all of the reports that happened on this page that I was just looking at and filter them. Now, we've got to give it 60 seconds to get through. Maybe I beat it to the page. So the other cool thing that I can show you just while the timer ticks over for that is if we go to the network tab and reload the page, you won't see any other additional traffic here. Now, Chrome used to show them in there. You would actually be able to see the HTTP post and the JSON going out of the back, but they're not reflected in the network tab anymore. Not entirely sure how I feel about that. I think it would be cool to still see them in there. So the browser will gather up the reports for the page. You can see there that keylogger.js, that the reason that it was blocked by the CSP, so that JavaScript file definitely did not load. Let me see if the time has passed. Still not passed yet. I'll come back to that one in a minute because it's got to send it and process it, go into my account. There's usually like a 60 or so second delay. The next one that I want to show is DMARC. Now, let's have a look here. I just usually Google this and just use the first link. MKai's fake, this sounds awesome. Let's use this one. So I just Googled send fake email for those that weren't looking, and I'm going to send an email from Troy Hunt. So we're going to try and send, like this will go fantastically well. troyhunt@hotmail.com. Nope, spelled that wrong. So it's from him, and it's going to me. Subject, what should we say? We'll send like password reset. Here we go. Can you tell that I can't use a non-ergonomic keyboard? There we go, password reset, text. Oh my God, hacksaws. It would be far more legitimate than that if I was actually going to send it. So, invalid receivers email to, oh, it wanted an email there. I see. There we go. Now, send. Do we get send? Okay, awesome. So that should be going to my Hotmail address. What I'm going to do, I'll wait until that email lands. And also, let me just go back over here. Did that land yet? Day, go. No, it's still not there. Interesting. So I don't want to load up my inbox on the main screen because I have no idea what kind of Viagra emails will be in there. So can I just like quickly load this up? Let me see if I can do this. Everyone put your cameras down. So go, click. No. Oh, it's okay. It's just GitHub emails. This is fine. So I'll open that in a new window. Just so like I can see this guy over here, hear him like click, click, click with his camera, taking pictures of my inbox for some reason. Now, this is kind of weird because this is exactly the behavior that we see on things like Office 365, where sometimes you might actually still get these emails to your inbox. Now, if you control the domain yourself and you can set SPF and you can set DKIM and you can set DMARC, you can prevent emails like this. And you literally saw, that's my inbox. So I can put this here so you can see inbox on the left-hand side. That's the top one that I just sent. Now, from my perspective, does this look legit? Does this look okay? I mean, like, to me, there's no real indicator, apart from the fact that it says, oh my God, hacksaws. Like, there's no indicator here that this is a non-legit email. Now, unfortunately, I don't control hotmail.com nor the settings that they do there. But if this was a domain, and I can go back and do the exact same thing again. So let's go back and do that exact same thing again. I'm going to go here, get rid of that. And where is my other browser window there? So we'll go to like send fake email in Google because that's literally all you have to do these days. Send fake email, fake emailer. And now I'll try and send one from my company. So from me, from email, my official, oops, there it was, to, we'll send it to my Hotmail so I can show it to you. And we'll do like password reset and, you know, spam, spam, spam. You wouldn't put that, but again, this is just to demonstrate the point. Now that's gone. Again, I'll wait here until this pops through. Make sure, see where it goes. So nothing in my inbox yet. Let me go over to junk email. Bam, there it is. So it's just landed in junk. Now, let me tab back over, hide all my emails. The Viagra ones were not mine. That one. So exactly the same website, exactly the same process, apart from like who I impersonated. Now, when you send the email, because I sent this one and it claimed to be from reporturi.com, and we take full control of these settings and specify that this should go to junk if it fails one of these checks. Now, of course it failed the check. I have no idea what this crazy website is that I just used, MKai's fake emailer, but they're sending it from an IP address that is not whitelisted in my SPF policy. They cannot sign it with my signature and prove it cryptographically. And that is the difference. This is where I want that email to go. I want it to go to spam. Very soon, I'm just going to tell them to delete it. I'm like just on the edge of turning on that nuke button. I want to make 100% sure that we're not deleting genuine emails. And that's what you should do too, right? Because you can take this tiered approach. So I've just realized I'm literally coming up on time, and I did want to take a couple of questions before I wrapped up. So I literally have, that wasn't me. Who's got the microphone in the audience? So, yeah, if there is a mic in there, that would be awesome. So I just do want to open it up. Literally, I've got like 1 minute left. I would love to take a couple of questions if there are any. I know I'm in Norway, and I'm asking the audience for questions. Apparently, this won't go well, someone told me. But I have faith. Is there anyone out there? Oh, I owe someone a beer if you don't ask me a question. Come on. Yes, there is like the guy in the clouds. Oh, you're going to have to shout so much louder than that. I'm sorry. And the lady with the microphone has to go up 874 steps to get to you. Can we like Dalmatians this, and can like you hear to him and relay to me? Is that possible? We'll fix this. Just don't change what he says, okay? Like, do we need a decryption key for what? Oh, for the relaying? Well, we have to trust the intermediary, and now everything is just totally blown.
Okay, my question was, is there a way for users to turn off reporting in the browsers? And isn't there a standard that actually makes this mandatory for browser implementations?
So I guess essentially the question there is around privacy. Like, can the users turn it off? Are you worried about speaking with a third-party service? So yeah, this is a thing that comes up a lot, and it's actually mentioned quite extensively in the specs, if you want to go read the RSCs as well. So to try and kind of summarize my view on this, it's like I go to the website, an error happens, and the browser is speaking to this third party that the user might not know about or something. Now, I think when a user goes to a website, they're essentially trusting that page to do the thing that the page needs to do. You could be loading JavaScript from anywhere, styles from anywhere. Like, you could be triggering all kind of outbound comms. The JavaScript itself can then make subsequent requests. So I feel that the reports fall inside the normal operation of a web page, in that you go to the page and that it will only do the things that that page needs. Because the kind of the flip side for this is you can also send these error reports from JavaScript if you want. If the page was doing that, then would it be different to native functionality doing it as well? No personal data ever gets sent, just to also clarify that point. Like, the report never contains anything about the user. I don't want or need to know anything about the user. I just need to know that my certificate's expired. I don't need to know who you are. I just need to know that my stuff is broken. So again, in the spec, it's very clear that there shouldn't ever be any information like about the user. So to answer the question very directly, no, you can't turn this off. It's built-in native functionality that's configured and controlled by the host that you're going to. That is my time, though. Sorry, I did want to take a couple more questions, but that demo ran slightly longer. I'm hanging around here if you want to grab me afterwards. I'm around NDC for the rest of the event, and hopefully I'll see you all on the conference floor. Thank you.